Welcome to Compounds, Elements, and Mixtures, an EOG review for 8th grade science. So recall that matter is anything that has mass and takes up space or has volume. Forms of energy such as heat, light, force are not matter, but pretty much everything else is. So from that, you can classify matter into one of two types. It's either a pure substance or it's a mixture. A pure substance is going to be an element. That's anything on that periodic table over there. Copper, nickel, helium, hydrogen, carbon, oxygen, nitrogen. All of those things are elements that can be found on your periodic table. A compound is the result of combining two or more of those elements via a chemical process, meaning they're bonding together with their electrons. That's still a pure substance, because it can't be broken down unless you put another chemical reaction on it. Where a mixture is something that's physically combined. Two or more substances that are physically bound. A homogeneous mixture, remember homo means same, so that means it's uniform or the same all the way through. Where heterogeneous is two or more substances that are, again, physically bound, so they're just kind of mixed together. There's no interaction with those electrons. They're just, the molecules are just kind of sitting, hanging out together. Heterogeneous means hetero, means different. So there's different parts, discernible different parts of that substance. A pure substance is an element, a single type of element exists on the periodic table. Now this does not mean a single atom. It can be way more than just one type, one amount, one quantity of atom, but it's going to be the same type. So for instance, aluminum foil. There's a lot of atoms here, but they're all the same type of atom. They're all aluminum, Al atoms. So they're all the same element. They can't be broken down chemically into any simpler substance. Aluminum is aluminum is aluminum. You cannot make this any more simple. But there's a lot of it. So an element can be a single atom. It can be many, 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 many atoms, as long as it's only one type. That's the part that confuses people, is that this is one type of atom. There's just lots and lots and lots and lots of them. So, gold bar, aluminum foil are some examples. Others are O2, right? It's two oxygen atoms.
Shelby Stewart and Ethan Freeman. Shelby Stewart and Ethan Freeman. Please report to Ms. Gibbs' office. Shelby Stewart and Ethan Freeman. Please report to Ms. Gibbs' office.
All right, also iron, Fe, helium gas. So look for those types of words. If you see just one element, that means, remember a capital letter if you're looking for chemical formulas. Every capital letter means it's a new element. So you can have multiple letters, like Fe is ferrous for iron. That's one element. There's only one capital letter there. So elements are going to have one capital letter. Another pure substance is a compound. This means it contains two or more types of atoms, meaning two or more different elements from the periodic table. They've chemically bonded together. Their electrons are either being shared or transferred. And it can only be separated into its parts as a result of a chemical reaction. So remember, when written as a chemical formula, an element will only have one capital letter, where a compound will have two or more capital letters. Examples of this are going to be like water, H2O, NaCl, or table salt, glucose, C6H12O6. Remember, anything from photosynthesis, all those compounds, carbon dioxide, hydrogen peroxide. You need to be able to recognize these common compounds, whether they are written out or whether they're in a chemical formula. Ammonia. So making a compound, a very simple chemical reaction here. Compounds are the result, again, of a chemical reaction. So here I've got some vinegar, which is itself just a solution. It's a mixture. And then I've got some baking soda, which is a pure substance. It's a compound. But when I put them together, you can see that something's being created here. Whoa, look at that gas. And that is carbon dioxide. That's a new compound. That's the result of some of the carbon atoms and the oxygen atoms from this acetic acid or vinegar and the sodium bicarbonate or the baking soda switching partners and deciding that they're going to make carbon dioxide, CO2, instead. So compounds, chemical reactions make compounds. Mixtures are just the result of physically combining one or more pure substances. Whether you're combining elements or you're combining different compounds, you're just physically mixing them together. I mean, they can be separated. They can be spun, boiled, sifted, and you can separate out those parts. Even sometimes you can just pick them apart. It's like a salad. So there's two types of mixtures. There's a homogeneous mixture, which means it's two or more substances not chemically bound. You can see I have a picture of tea here. It's uniform. I mean, it's the same all the way through, front to back. It looks like one thing, but it can be physically separated. An example of a homogeneous mixture that I have here is some Nutella, right? Oof, someone put some stuff in here. But there's all sorts of stuff in here. I can look at this ingredient list and see, oh, there's sugar, palm oil, hazelnuts, cocoa, skim milk. But even so, it's starting, it can be separated if I leave it long enough. If I want to boil it or sift it or spin it, I could probably separate out these parts. But there is a homogeneous mixture. Gross. All right. Other examples of homogeneous mixtures are going to be like anything with the word solution in it. That's just a fancy word for saying homogeneous mixture. It means it's two or more things mixed together really, really, really well. So anything with solution, you should be thinking homogeneous mixture right away. Alloys are another tricky one. Remember, that's just two metals that have been mixed together. So brass, steel, solder, those are tricky because some people are going to think those are elements, but those particular ones, alloys, are a homogeneous mixture of two metals combined. Blood is a really big one. I don't have to go to the doctor. I'm not going to get pricked in the arm and have one result on my blood sugar and then be pricked in the leg and have a different result. It's the same all the way through my body. There's a whole bunch of different things in there. Oxygen, iron, right? All my little food particles, but they're evenly dispersed more or less throughout my body, so it's a homogeneous mixture. Kool-Aid, iced tea. Notice there's no chemical formulas here. If there was a chemical formula, that takes us back to our compounds. So homogeneous mixtures, same all the way through, front to back, top to bottom. You're going to get the same percentages or concentrations of the different things that make up that mixture if you take a sample from the bottom or from the top or from one time versus the next. Or heterogeneous mixtures, again, are two or more substances not chemically bound, such as any mixture, but they're non-uniform. Remember, hetero means different, so it's not the same through and through. You can look at the salad that I have pictured there, and you can easily, like, I don't want the tomatoes, and pull those apart very easily. So it can be physically separated, boil it, spin it, sift it, and you can separate out its parts. So examples of heterogeneous mixtures include pizza, salad, ocean water, concrete, chunky soup, density column. So don't be tricked because ocean water is different than the compound H2O. Think about all the things that are in the ocean. There's pollution, there's salt, there's fish. If I put a scoop here and I have one bass, I'm not going to go somewhere else and exactly be guaranteed that if I take the same exact sample size, I'm going to get one bass. A density column. Here, I can add some corn syrup here. Oy, if I can get it open. And I can add that and squeeze some in there. All right, and then I can add some just colored water that I have over here. And I can add some giant size oil here. And you can see those are different layers. They are separated out. You can very easily see the corn syrup on the bottom, the water, and then the vegetable oil on top. They're separated by density there. So you can easily separate out those parts. That is not homogeneous. That is a heterogeneous mixture right there. And if I were to mix that up, they're still going to separate back out, and that's because of a physical property. They've been physically combined. They've just been mixed together. So remember, if you're you're going to first identify your matter as either a pure substance, which means it's chemically combined, or a mixture, which means it's physically combined. If it's a pure substance, you've only got two choices. It's either one element, in which case it's an element, big surprise there, or it's more than one element, which is a compound. So more than one element is going to be a compound. They are chemically combined. So that means their electrons are interacting. You're going to look for a chemical formula there. If it's a mixture, if it's uniform, if it's the same all the way through, homogeneous. If it's non-uniform, like our density column here, or pizza, or salad, those are really common examples. Non-uniform means heterogeneous. So again, this is a review of compounds, elements, and mixtures for chemistry unit of 8th grade science. Thank you.